In this video, we'll look at how to add two vectors when we only know their directions and magnitudes. We'll see that the best way to do this is to first find the components of the vectors. So let's take two vectors, but rather than giving them in component form, let's just give their directions and magnitudes. So first we have A, which has magnitude 3 and direction 60 degrees, and we also have B, which has magnitude √3 and direction 225 degrees. Let's look at these on the axes. Here's A, and here's B. Using my axes, I've tried to draw my two vectors as accurately as possible, but it's important to note that when sketching vectors with pencil and paper, you don't need a 100% accurate drawing. We're going to construct a diagram based on this sketch, but as long as we label everything correctly, it doesn't matter if everything is drawn completely accurately. Okay, so let's label these sketches with the information we have. So this length is 3, and this angle is 60 degrees. Similarly, this length is √3, and this angle is 45 degrees. If you're unsure where we got 45, simply note that this whole angle here is 225 degrees, since it's the direction of B, and this angle is of course 180 degrees, so we do 225 minus 180 to get 45. Now, let's make two right-angled triangles out of these vectors, like this. So our task is to add the two vectors together. Another way to say this is to find the resultant of the two vectors, since the resultant just means the sum. But as I said, we'll start by finding the components of the two vectors A and B. Let's label them on the diagram. So the components of A, which we'll call x1 and y1, are this length and this length, the remaining two sides of this triangle. Similarly, the components of B, x2 and y2, are the remaining two sides of the other triangle. It's now just a case of using trigonometry to find the missing lengths. Let's very quickly remind ourselves of the method. Hopefully you can remember the mnemonic SOHCAHTOA, which tells us how various trigonometric functions can be used to relate side lengths and angles in a right-angled triangle. So, if we have such a triangle, with one of the angles labelled theta, and the three sides labelled A for the adjacent to theta, O for the opposite to theta, and H for the hypotenuse, then SOHCAHTOA tells us that sine theta equals O over H, cos theta equals A over H, and tan theta equals O over A. If you don't remember this, I suggest you revise it. So, let's find the components. We'll start with A. From the diagram, and using SOHCAHTOA as we just discussed, we find that cos 60 equals x1 over 3, which gives us that x1 equals 3 cos 60, which is equal to 1.5. We also know that sine 60 is equal to y1 over 3, so y1 equals 3 sine 60, which is approximately equal to 2.6. We do something very similar for B now, and we get that cos 45 equals x2 over √3, so x2 equals √3 cos 45, which is approximately 1.2, and sine 45 equals y2 over √3, so y2 equals √3 sine 45, which is approximately 1.2 also. So A equals 1.5i plus 2.5j, and B equals minus 1.2i minus 1.2j. Note, we require the minuses for B since B is in the minus x minus y quadrant. So all that's left is to calculate their resultant, which is now a very straightforward task. We have that A plus B is 1.5i plus 2.6j plus minus 1.2i minus 1.2j, which, with some rearranging, is equal to 1.5i minus 1.2i plus 2.6j minus 1.2j, which finally is equal to 0.3i plus 1.4j.
Mountains and the stars. blew a soft wind, as if that